Hi. Today I'm going to tell you 100 sleepy facts about lava, perfect if you want to relax a bit and learn something interesting about this fiery natural force. Enjoy listening. 1. Lava is molten rock expelled by volcanoes. Lava originates from the Earth's mantle and crust. When pressure builds beneath the surface, magma erupts as lava. It can flow, explode, or form domes depending on its viscosity. Lava is responsible for shaping landscapes during volcanic activity. 2. Lava is extremely hot. Lava temperatures typically range from 700 degrees Celsius to 1,200 degrees Celsius, 1,300 degrees Fahrenheit to 2,200 degrees Fahrenheit. The heat can easily ignite vegetation, melt metals, and cause severe burns. Its high temperature also allows it to flow for kilometers before cooling. The temperature depends on its chemical composition and gas content. 3. Lava becomes solid rock when it cools. Once lava cools, it forms igneous rock such as basalt or andesite. Cooling speed affects the rock's texture. Rapid cooling forms volcanic glass, while slow cooling creates crystals. Solidified lava can create cliffs, plateaus, and lava fields. Over time, these formations become part of the Earth's crust. 4. Lava can flow like a river or explode violently. Low-viscosity lava flows easily, spreading over large areas. High-viscosity lava tends to pile up, forming domes or causing explosive eruptions. The flow type affects nearby communities and the surrounding landscape. Volcanologists monitor lava behavior to predict hazards. 5. Lava contains dissolved gases. Gases like water vapor, carbon dioxide, and sulfur dioxide are trapped in lava. These gases escape during eruptions, sometimes causing explosions. Gas content influences lava viscosity and eruption style. Volcanic gas emissions also affect climate and air quality. 6. Lava flows can destroy anything in their path. Buildings, roads, forests, and farmland are vulnerable to lava. Despite its slow movement, lava's extreme heat incinerates most obstacles. People often evacuate areas to avoid injury or death. However, some ecosystems eventually recover after lava cools. 7. Lava comes in different types. The main types are basaltic, andesitic, dacitic, and rhyolitic lava. Basaltic lava is fluid and fast-flowing, while rhyolitic lava is thick and sticky. Each type has unique chemical composition, eruption style, and cooling behavior. Understanding lava type is crucial for hazard assessment. 8. Lava is different from magma. Magma is molten rock beneath the Earth's surface, while lava is magma that reaches the surface. Once exposed, lava loses some gases and cools rapidly. Magma contains more volatiles and is under higher pressure. The transition from magma to lava affects eruption dynamics. 9. Lava can form lava tubes. As lava flows, the surface may cool and solidify, creating a crust. Beneath the crust, molten lava continues to flow, forming hollow tubes. Lava tubes can transport lava for kilometers and later become caves. They are natural wonders and sometimes tourist attractions. 10. Lava is rich in minerals. Lava contains silicate minerals like olivine, pyroxene, and feldspar. These minerals crystallize as lava cools, forming igneous rocks. Lava also carries metals like iron, magnesium, and calcium. The mineral content influences lava color, density, and viscosity. 11. Lava can trigger wildfires. The extreme heat of lava can ignite forests, grasslands, and homes. Smoke and ash from burning vegetation reduce air quality. Lava-triggered fires pose additional hazards during volcanic eruptions. Firefighting in lava-affected areas is usually impossible. 12. Lava flows slowly compared to other natural hazards. Basaltic lava can flow at a few kilometers per hour, giving people time to evacuate. However, its slow movement does not make it less destructive. The heat can still burn anything it touches. Some eruptions produce lava flows that cover tens of kilometers. 13. Lava can create new land. When lava enters oceans, it cools rapidly and solidifies, forming new land. The Hawaiian Islands, for example, were created by lava flows. Lava builds volcanic islands and extends coastlines. This process contributes to the dynamic reshaping of Earth's surface. 14. Lava can form pillow lava underwater. When lava erupts underwater, it cools quickly, forming rounded, pillow-shaped structures. Pillow lava is common at mid-ocean ridges and submarine volcanoes. Its unique shape results from rapid cooling in water. Studying pillow lava helps scientists understand underwater eruptions. 15. Lava color depends on temperature and composition. Hot lava appears bright red, orange, or yellow, while cooler lava looks dark brown or black. Mineral content and oxidation also affect color. Lava color can indicate temperature and eruption style. Observing lava helps volcanologists assess hazards. 16. Lava is denser than water. The density of lava ranges from 2.5 to 3 grams per cubic centimeter. Its high density prevents it from floating and allows it to flow along slopes. This property contributes to its destructive ability. Density varies with chemical composition and temperature. 17. Lava can flow under ice. When volcanoes erupt under glaciers or ice caps, lava melts the ice, causing floods called jokull-lops. Lava-ice interactions can trigger explosive eruptions. These events are common in Iceland and Antarctica. They create unique landforms and hazards. 18. Lava produces volcanic gases. As lava cools, gases escape into the atmosphere. These include sulfur dioxide, carbon dioxide, and water vapor. Gases can create acid rain, smog, and climate effects. Monitoring gas emissions helps predict volcanic activity. 19. Lava can form basalt columns. As lava cools slowly, it contracts and fractures into hexagonal columns. Famous examples include the Giant's Causeway in Ireland. Columnar jointing forms striking, geometric patterns in volcanic rock. This phenomenon illustrates the interplay between cooling and contraction. 20. Lava has been used in construction. Historically, cooled lava rock has been used for building homes, walls, and roads. Basalt and pumice are durable, lightweight, and heat-resistant. Some cultures, like in Hawaii, continue to use lava stone in construction. Lava contributes both to hazards and human resources. 21. Lava viscosity affects flow speed. Low viscosity lava, like basaltic lava, flows quickly and can travel long distances. High viscosity lava, such as rhyolitic lava, moves slowly and piles up near the vent. Viscosity depends on temperature, silica content, and gas presence. Understanding viscosity helps predict lava hazards during eruptions. 22. Lava can cause pyroclastic flows. Although lava itself is molten, it can trigger pyroclastic flows if mixed with gases and fragmented material. Pyroclastic flows are fast-moving, deadly clouds of hot gas and volcanic rock. They can travel hundreds of kilometers per hour. Pyroclastic flows are among the most lethal volcanic hazards. 23. Lava creates fertile soils. Once cooled and weathered, lava breaks down into mineral-rich soil. Volcanic soils are often highly fertile and support agriculture. Crops like coffee, grapes, and vegetables thrive in these soils. This shows how lava can eventually benefit ecosystems and humans. 24. Lava can destroy infrastructure. Buildings, roads, and bridges are highly vulnerable to lava flows. Even modern materials like asphalt and concrete are quickly incinerated. Lava-induced destruction requires evacuation and reconstruction. Cities near volcanoes often have evacuation plans for lava hazards. 25. Lava flows can form lava deltas. When lava enters water, it can accumulate and form new land masses called lava deltas. These formations extend coastlines and create new habitats. Lava deltas are unstable and can collapse, causing hazards. They illustrate the powerful interaction between lava and water. 26. Lava produces volcanic glass. Rapidly cooled lava can form obsidian, a natural volcanic glass. Obsidian is sharp, brittle, and was historically used for tools and weapons. Cooling speed determines whether lava forms glass or crystalline rock. Volcanic glass is a key indicator of eruption conditions. 27. Lava eruptions release energy. Lava eruptions release vast amounts of thermal and mechanical energy. This energy drives flows, explosions, and lava fountains. It can alter landscapes, destroy ecosystems, and influence climate temporarily. Volcanologists study eruption energy to understand hazards and predict activity. 28. Lava flows follow topography. Lava travels downhill, following valleys, slopes, and channels. Its path is influenced by viscosity, eruption rate, and obstacles. Low areas are at higher risk during eruptions. Mapping topography helps predict lava flow paths. 29. Lava can generate lightning. Volcanic eruptions, especially explosive ones, can produce lightning in ash plumes. Friction between volcanic particles charges the plume electrically. Lava indirectly contributes by fragmenting rock and gas during eruptions. Volcanic lightning is both dangerous and spectacular. 30. Lava can create lava fountains. Some eruptions eject lava high into the air in spectacular fountains. Lava fountains result from high gas pressure beneath the surface. They can reach hundreds of meters in height. Lava fountains distribute molten rock over a wide area. 31. Lava forms Pahoehoe and Aa types. Pahoehoe lava is smooth, rope-like, and flows easily. Aa lava is rough, jagged, and moves slower. Both types are basaltic but differ due to cooling rate and gas content. The flow type influences hazards and landscape formation. 32. Lava can trap air pockets. As lava cools, gases can become trapped, forming vesicles or bubbles. These vesicles create porous rocks like pumice. Pumice can float on water despite being volcanic rock. Air pockets also influence rock strength and texture. 33. Lava flows can start fires. Vegetation and structures in the path of lava can ignite due to extreme heat. Fires add to the destruction caused by lava alone. Smoke and ash from burning materials reduce air quality. Lava-induced fires make eruptions even more hazardous. 34. Lava can reach oceans and steam violently. When lava enters seawater, it causes rapid cooling and explosive steam eruptions. This can create laze, a mix of lava, steam, and hydrochloric acid. Laze is toxic and dangerous to anyone nearby. Interaction with water can increase eruption hazards. 35. Lava contains dissolved crystals. Molten lava often has tiny crystals of minerals suspended within it. These crystals grow as lava cools and solidifies. The type and amount of crystals affect lava texture and flow behavior. Crystals also provide clues about magma formation and cooling history. 36. Lava contributes to volcanic hazards worldwide. Lava flows are common hazards near volcanoes like Kilauea in Hawaii or Etna in Italy. They destroy property, alter landscapes, and threaten lives. Despite slow speed, lava's heat and reach make it deadly. Understanding lava hazards is essential for risk management. 37. Lava forms lava plains. Extensive lava flows can create flat, wide plains over time. These lava plains can cover thousands of square kilometers. They often form from repeated basaltic eruptions. Lava plains impact ecosystems and human settlement patterns. 38. Lava can produce lava bombs. During eruptions, molten lava can be ejected as large fragments called lava bombs. Lava bombs cool partially in the air but remain hot and molten inside. They can travel long distances and cause injuries or damage. Lava bombs illustrate the explosive power of eruptions. 39. Lava is monitored for volcanic prediction. Volcanologists track lava flows, temperature, gas emissions, and chemical composition. Monitoring helps predict eruption timing, flow paths, and hazards. Technologies include thermal imaging, drones, and satellite observation. Lava monitoring saves lives and property. 40. Lava interacts with ecosystems. Initial lava flows destroy vegetation and wildlife habitats. Over time, weathering and soil formation allow new ecosystems to develop. Some plants and animals are specially adapted to volcanic landscapes. Lava thus plays a role in ecological succession and biodiversity. 41. Lava can form lava domes. High-viscosity lava can pile up near the volcanic vent, creating a dome shape. Lava domes grow slowly but can collapse suddenly, causing pyroclastic flows. They are common in stratovolcanoes like Mount St. Helens. Dome formation is closely monitored due to potential hazards. 42. Lava can produce volcanic ash. Explosive eruptions break lava into fine particles called ash. Ash can travel hundreds of kilometers, affecting air quality, agriculture, and aviation. It can also blanket towns and landscapes, causing damage. Ash from lava eruptions is an important factor in volcanic hazards. 43. Lava can flow underwater. Submarine eruptions create lava flows that form new seafloor. The rapid cooling by water forms structures like pillow lava. Underwater lava contributes to oceanic crust formation. Studying these flows helps scientists understand plate tectonics. 44. Lava interacts with glaciers in ice-covered regions. When lava erupts under ice, it melts glaciers and can trigger floods called jokullops. The interaction can produce explosive eruptions and unique landforms. Iceland is famous for such volcanic ice interactions. Lava ice events illustrate how geology and climate intersect. 45. Lava can trigger lahars. Lava flows melting snow or ice can mix with debris to form destructive mudflows called lahars. Lahars travel quickly down river valleys, destroying everything in their path. They are particularly dangerous during volcanic eruptions in mountainous regions. Lava indirectly contributes to these deadly flows. 46. Lava can create lava caves. Lava tubes may remain hollow after molten lava drains away. These caves can be explored and studied by geologists and adventurers. Lava caves provide insights into the flow patterns and eruption history. They are also habitats for unique species. 47. Lava can form scoria. Scoria is a porous volcanic rock formed when gas-rich lava cools quickly. It has many holes from trapped gas bubbles. Scoria is lighter than solid lava and often used in landscaping and construction. Its formation illustrates gas interactions in lava. 48. Lava affects local climate temporarily. Large eruptions with lava and ash release heat and gases into the atmosphere. Sulfur dioxide can form aerosols, reflecting sunlight and cooling the local climate temporarily. Volcanic heat can also create localized wind patterns. Lava plays a role in short-term climate effects. 49. Lava is studied using thermal imaging. Scientists use infrared cameras to track lava temperature and flow. Thermal imaging helps predict lava paths and assess eruption intensity. It allows safe observation from a distance. Monitoring thermal patterns is essential for hazard management. 50. Lava produces fumaroles. After lava flows, steam and gas vents called fumaroles can form on solidified surfaces. Fumaroles release water vapor, sulfur gases, and other compounds. They indicate ongoing geothermal activity. Fumaroles are important for volcanic monitoring and tourism. 51. Lava flows can create lava plateaus. Repeated lava eruptions over time can form wide, elevated plains known as lava plateaus. The Deccan Traps in India are an example. Plateaus impact geography, climate, and human settlement. They reflect the long-term geological impact of lava. 52. Lava can produce volcanic lightning. Volcanic eruptions, especially explosive ones, can generate lightning in ash plumes. Friction between ash particles charges the plume electrically. Lightning adds danger and awe to volcanic activity. Lava contributes indirectly by producing ash and gases. 53. Lava can create unique rock formations. As lava cools and contracts, it forms columnar basalt, pillow lava, and lava ridges. These formations are not only geologically significant but also visually striking. They tell the history of eruptions and lava behavior. Many are protected as natural monuments. 54. Lava can cause secondary hazards. Apart from direct burns, lava can trigger fires, lahars, gas poisoning, and structural collapses. Secondary hazards increase the risk to humans and wildlife. Understanding lava hazards involves studying all direct and indirect effects. Risk mitigation often includes evacuation and planning. 55. Lava flow paths can be predicted. Geologists use slope maps, viscosity, eruption rate, and historical data to predict lava paths. Predicting flow paths helps in planning evacuations and building defenses. While predictions are not perfect, they reduce casualties and damage. Technology, including drones and satellites, improves accuracy. 56. Lava releases sulfur dioxide gas. Sulfur dioxide, SO2, is a common volcanic gas emitted during lava eruptions. SO2 can form acid rain and air pollution. It also contributes to climate effects by reflecting sunlight. Monitoring SO2 is critical for public health and environmental protection. 57. Lava can travel underground. Some lava flows beneath the surface in lava tubes or fissures. Underground flows are hidden hazards and can emerge unpredictably. These flows maintain high temperatures longer. Studying subsurface lava helps understand eruption dynamics. 58. Lava can produce volcanic bombs. Explosive eruptions can fling chunks of lava called volcanic bombs. These bombs cool partially during flight but remain molten inside. They can be dangerous over large distances. Their size and trajectory depend on eruption force and viscosity. 59. Lava interacts with vegetation. When lava reaches forests or grasslands, it burns or buries plants. Initial destruction is severe, but over time, soils formed from lava support new vegetation. Lava thus resets ecosystems but eventually contributes to biodiversity. Ecological recovery can take decades or centuries. 60. Lava flows have shaped human history. Many civilizations have been affected by volcanic lava flows, from destruction to fertile soils. Ancient Hawaiians, Romans near Vesuvius, and others witnessed lava shaping landscapes and settlements. Human adaptation to lava hazards includes settlement planning and building practices. Lava's impact on humans is both destructive and beneficial. 61. Lava can cause earthquakes. The movement of magma beneath the surface and the eruption of lava can trigger seismic activity. These earthquakes are usually shallow and localized near the volcano. They can precede eruptions, serving as warning signs. Studying these quakes helps volcanologists predict volcanic activity. 62. Lava can create lava fountains. Lava fountains occur when gas-rich magma is ejected high into the air. These fountains can reach hundreds of meters in height. Lava fountains distribute molten rock over a wide area. They are often seen in Hawaiian-style eruptions and are spectacular to observe. 63. Lava can form black sand beaches. When lava enters the ocean and cools rapidly, it can fragment into fine particles. These particles accumulate to form black sand beaches. Hawaii has famous black sand beaches created from lava. This process illustrates how lava interacts with the environment to create unique landscapes. 64. Lava can alter rivers and streams. Flowing lava can block rivers, creating temporary lakes or changing drainage paths. Once cooled, it forms solid barriers, permanently altering water flow. These changes can affect ecosystems and human settlements. Volcanologists monitor lava paths to anticipate such impacts. 65. Lava can produce volcanic glass shards. Rapidly cooling lava forms obsidian or volcanic glass. The shards are sharp and brittle. Obsidian was historically used to make tools and weapons. Volcanic glass is an important record of eruption conditions. 66. Lava can contain xenoliths. Sometimes lava carries fragments of pre-existing rock called xenoliths. These rocks originate from the crust or mantle and are incorporated during eruption. Xenoliths provide geologists with insights into Earth's interior. They reveal the composition and temperature of deep rock layers. 67. Lava can produce lava balloons. In underwater eruptions, gas-rich lava may form buoyant bubbles called lava balloons. These balloons can float on water before cooling and sinking. Lava balloons demonstrate the interaction between molten rock and gases. They are rare but interesting volcanic phenomena. 68. Lava can generate acid rain. Volcanic gases released from lava, particularly sulfur dioxide, combine with water in the atmosphere. This reaction forms sulfuric acid, resulting in acid rain. Acid rain can damage crops, vegetation, and infrastructure. Lava eruptions thus have environmental effects beyond immediate lava flows. 69. Lava can create volcanic islands. Repeated lava eruptions in oceans can build up enough material to form islands. The Hawaiian Islands are classic examples of volcanic islands formed by lava. Lava adds landmass and changes geography over time. These islands support unique ecosystems and human settlement. 70. Lava can produce pyroclastic surges. Although lava is molten, explosive eruptions can fragment it into fast-moving clouds of ash, gas, and rock called pyroclastic surges. These surges are deadly and travel at high speeds. Lava contributes to these events when gases expand rapidly. Pyroclastic surges are one of the most dangerous volcanic hazards. 71. Lava can affect air quality. Volcanic gases from lava, including sulfur dioxide and carbon dioxide, reduce air quality. Ash particles suspended in the air can irritate lungs and eyes. Prolonged exposure can be harmful to humans and animals. Monitoring air quality during eruptions is essential for public health. 72. Lava can generate lahars when mixed with water. Lava melting snow, ice, or rainwater can mix with debris to create fast-moving mud flows. Lahars can destroy infrastructure and cause fatalities far from the volcano. They are secondary hazards related to lava activity. Early warning systems help mitigate risks. 73. Lava can solidify into tuff. When lava interacts with water or air violently, it can fragment into fine ash that later consolidates into tuff. Tuff is a light, porous rock often used in construction. It forms from explosive eruptions and lava fragmentation. Studying tuff layers helps understand eruption history. 74. Lava can generate volcanic tremors. The movement of molten lava beneath the surface produces continuous low-frequency vibrations. These tremors are distinct from standard earthquakes. Monitoring tremors provides clues about magma movement and eruption likelihood. They are part of volcanic seismic activity analysis. 75. Lava can form lava terraces. Repeated lava flows can create step-like formations on volcanic slopes. Lava terraces indicate successive eruption events. They provide insights into the eruption sequence and lava volume. Terraces also affect local topography and drainage. 76. Lava can cool unevenly, creating cracks. As lava cools, contraction can cause fractures or polygonal cracks. Columnar basalt is a famous example of this process. Cracking affects rock stability and erosion patterns. Geologists study these cracks to understand cooling rates and lava composition. 77. Lava can release carbon dioxide. Molten lava contains dissolved CO2 that escapes during eruptions. This contributes to greenhouse gases and atmospheric chemistry changes. Large eruptions can have temporary climate effects. Monitoring CO2 helps understand volcanic and environmental impacts. 78. Lava can be acidic or basic depending on composition. Silica-rich lava, rhyolite, is acidic, while basaltic lava is more basic, low silica. Chemical composition affects viscosity, eruption style, and rock type. Acidic lava tends to be more explosive, while basic lava flows more fluidly. Composition analysis aids volcanic hazard prediction. 79. Lava can produce lava spines. Viscous lava can extrude slowly to form vertical spires called lava spines. Lava spines are unstable and may collapse, generating pyroclastic flows. They are typically found in andesitic or dacitic eruptions. Observing spines provides insights into eruption dynamics. 80. Lava contributes to geothermal energy. Residual heat from lava and magma can be harnessed for geothermal power. Hot rocks beneath the surface heat water, creating steam for electricity generation. Geothermal energy is renewable and environmentally friendly. Lava is therefore a source of clean energy potential. 81. Lava can produce lava cascades. During eruptions, lava can flow over cliffs or steep slopes, creating cascading streams. These lava cascades move quickly due to gravity. They shape the surrounding landscape and carve channels in rock. Observing cascades helps scientists understand eruption dynamics and flow behavior. 82. Lava can form lava ponds. Sometimes lava pools in depressions near the vent, forming lava ponds. These ponds remain molten for days or weeks depending on flow and cooling. Lava ponds are sources of lava for further flows. Studying them helps monitor eruption intensity and hazards. 83. Lava can cause roof collapses. If lava flows into settlements, the weight of cooled lava can collapse buildings. Roofs are especially vulnerable if ash accumulates or lava partially solidifies on them. This destruction demonstrates the secondary structural hazards of lava. Human settlements near volcanoes must consider lava risk in construction. 84. Lava can form lava fountains underwater. Submarine eruptions can produce vertical lava fountains beneath water. Steam and gas expansion propel molten rock upward. These fountains contribute to seafloor formation and create unique volcanic features. They demonstrate lava's interaction with water and pressure. 85. Lava can form lava shields. Low-viscosity lava flows can build gently sloping shield volcanoes over time. The Hawaiian Islands are examples of shield volcanoes formed by basaltic lava. Shield volcanoes are characterized by broad, rounded profiles. Their formation shows how lava shapes large-scale landforms. 86. Lava can produce volcanic smog, VOG. Volcanic gases released from lava combine with atmospheric moisture to form VOG. VOG can reduce air quality, cause respiratory problems, and impact visibility. Areas downwind of active lava flows are often affected. VOG highlights lava's environmental impact beyond the ground. 87. Lava can create lava cliffs. Solidified lava flows that erode slowly can form steep cliffs. These cliffs are often composed of resistant basalt or andesite. Lava cliffs affect erosion patterns, drainage, and local topography. They are prominent features in volcanic landscapes worldwide. 88. Lava interacts with soil formation. Once cooled and weathered, lava contributes minerals to soil formation. Volcanic soils are often fertile, supporting agriculture and vegetation. This transformation illustrates lava's long-term ecological contribution. Fertile soils from lava are found in many volcanic regions. 89. Lava can form lava rivers. During large eruptions, lava can flow in wide, river-like streams. These lava rivers follow valleys and channels, sometimes traveling kilometers. They carve their path through terrain, shaping landscapes over time. Lava rivers are a spectacular display of molten rock movement. 90. Lava can create lava cascades in urban areas. In cities near volcanoes, lava can flow over streets and structures like cascading water. The intense heat destroys everything in its path. Urban lava cascades require careful monitoring and evacuation. They illustrate the hazards of living close to active volcanoes. 91. Lava can carry minerals from deep earth. Lava transports minerals from the mantle and crust to the surface. These minerals provide geologists with information about Earth's interior. Studying lava compositions helps understand mantle chemistry and tectonic processes. Lava serves as a window into deep earth processes. 92. Lava can be a tourist attraction. Many volcanic regions attract tourists to see lava flows safely from a distance. Hawaii, Iceland, and Italy offer viewing areas for active lava. Tourists learn about volcanic activity while enjoying natural spectacle. Lava tourism highlights both danger and fascination. 93. Lava can generate heat for traditional uses. Historically, lava heat was used to cook food or warm homes in volcanic regions. Hot rocks and lava channels could provide energy for local communities. This shows human adaptation to volcanic environments. Lava contributed to survival and cultural practices. 94. Lava can form lava pinnacles. Viscous lava can harden into tall, narrow rock formations called pinnacles. These structures are often unstable and prone to collapse. Lava pinnacles are indicators of past eruption dynamics. They are studied for insights into lava viscosity and flow behavior. 95. Lava can affect groundwater. Hot lava flows can heat and alter groundwater systems. This can change water chemistry, temperature, and availability. In some cases, lava can block or redirect aquifers. Monitoring water near lava flows is important for communities and ecosystems. 96. Lava can produce lava splatter cones. Small eruptions of lava can build splatter cones near vents. Lava fragments accumulate to form mounds with steep sides. These features indicate localized eruption activity. Studying splatter cones helps volcanologists understand lava eruption patterns. 97. Lava flows can solidify into layered rock. Repeated eruptions can create stratified lava layers. Each layer represents a distinct eruption event. Stratification helps geologists reconstruct volcanic history. These layers also influence erosion and landscape evolution. 98. Lava can create lava bridges. In some cases, cooled lava spans gaps in terrain, forming natural bridges. These formations are rare and fragile. Lava bridges illustrate lava's ability to create unusual landforms. They are studied for geological and aesthetic significance. 99. Lava can produce volcanic caves. Lava tubes often evolve into caves after lava drains away. These caves provide shelter for animals and sometimes humans. They offer insights into the movement and cooling of lava. Lava caves are explored for geology and adventure tourism. 100. Lava plays a crucial role in Earth's geology. Lava constantly reshapes landscapes, forms rocks, and builds landforms. It contributes to soil fertility, ecosystems, and geothermal energy. Lava provides clues about Earth's interior, tectonics, and volcanic hazards. Despite its danger, lava is essential to the planet's dynamic processes.